Alright, first you need to get this chart in your notes as soon as I get it up there. Right there. There you go. I don't know what it'll look like if I zoom it in for you. Let me work it on that. You do that and then scoot it down in a minute. Is that better?
We're supposed to write that down.
There you go. That has it all on there. And we've done these transformations before. We've done them with parabolas. We did them with absolute value graphs. So this stuff is all the same. Remember, if it was like in the parentheses, it scooted it left and right. That's what that top one says. If it stuck out on the end, it scooted it up and down. That's what the second one says. Reflections came when we put negatives. That's what the third one says. So the stuff is the same. It's just looking at them on different types of graphs now. We're getting close. Okay. Hey. Yep. The one. Hey Anna, will you hit that switch that's down? Alright, we're about ready. Anybody need another second? Okay. Alright, so what we're going to look at here, we've got the original function, the original graph says f of x equals x cubed, and then its transformation is g of x equals x plus 5 cubed plus 2. Okay, so the directions say describe the transformation and then graph. So we're going to describe the transformation first before we look at the graph. Alright, so I see two things that have happened to it. In with the x, it's got a plus 5. So looking on your chart, or remembering from when we did parabolas and absolute values, when it's in with the x, what does that do to it? How does that move it? Horizontally. And since it's plus 5, isn't it the opposite way? So this one would actually go left 5 units. Then what about this plus 2 out here on the end? What would that do to it? Up 2 units. Okay? Alright, now if we're going to graph this one here, I'm going to, this is going to be my x cubed. Just cube all those. Negative 2 cubed is negative 8, negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So if I went left 2, I'm doing the first point, down 8, left 1, down 1, 0, 0, 1, 1, and then 2, 8. Y-axis are leaning, didn't it? Alright, so it would be the snake-looking graph that goes through those points. And you could get it on your calculator if you wanted to and look at that. Alright, now, I could make another input-output table for g of x here if I wanted to, but I don't have to now. I can just take all these points and scoot them left 5 and up 2. So let me do that one in a different color. Take all these points and scoot them left 5. So I'm going to start here with that one at the origin. 1, 2, 3, 4, 5, and up 2. Left 5, 1, 2, 3, 4, 5, and up 2. Left 5, 1, oh, that was 2. 1, 2, 3, 4, 5, and up 2. Down here, left 1, 2, 3, 4, 5, up 2. And then left 5 and up 2. So it would be the same thing, same shape and everything, just scooted left 5 and up 2. So your main dilemma is just going to be recognizing what is done to it, describing the transformation. But we've done that a lot a couple months ago with parabolas and with absolute value graphs. It's all the same stuff. It's all that chart is the same. I think I made you just write it all down last time we went through it and wrote it down with my handwriting, but I took a picture of the chart this time. All right, ready to look at another one? You got what you need on that one? Okay. Here, f of x is equal to x to the 4th. The transformation, g of x, is equal to negative 1/4 x to the 4th. Alright, so describe the transformation.
Straighten my negative one.
Okay.
Failure reflection versus the negative, right?
Well, we could say whichever one we want to first. It's fine on that. Y'all both, if we put Kylie and Macy's answer together, they're both right. It's that 1/4. If you look at your chart, that 1/4 is just out in front of the variable. So that's just like the very last thing that you copied there. A shrink of 1/4. Is it a vertical or a horizontal shrink? Vertical. And then the negative out in front, if you go up to your reflection there, you see that that is reflected over. That's it. Do y'all know how to graph in your calculator? Do we need to spend time on that? Y'all know how to do that? Y equals that very top row up under the screen. Y equals, and just type on both ends. So this one's actually kind of cool. It kind of looks like a fat parabola. And then the one underneath it is just a little bit bigger. Now, why is the one underneath it bigger, but y'all said it was a shrink? You shrunk by something small, right? Gracie? These are each, yes, that's the better way, mathematical way of saying it. Each of those is closer to the x-axis. Did y'all get, those y'all that were trying it on your calculator, did y'all see something like that? What'd you see? Ooh, hit y equals, let me check you out. Oh, you gotta divide in there. Read on that now. It's still taking off. There it goes. Did it get anything off there? Oh, it hit. Okay, go back to y equals. I hit zoom. Well, 6. Anybody else need some looking on your calculator? Yes. Yes. Okay, that's good. So that's the bottom one. So if you wanted to see the top one.
I played my part to that
Alright, let's see here. If our f of x is x to the 5th, we transform this dude into g of x, which is 2x to the 5th minus 3. Alright. What happened to it? Say it. It is not a vertical stretch.
Oh, it stretched of one line, and then it went down.
I'm with David on that. Yeah, that's 2. This is a horizontal shrink of 1/2 and down 3. Okay, that was one of the reasons why I wanted you to copy that chart, is because this looks exactly like it does in the chart. The 2x is in the parentheses with the exponent, so you just go and look through there in the examples. And there on horizontal shrink, you see one that looks just like it. Right?
So if that was like the reciprocal, so like if that was 3, it would have been 1/3.
Yes, ma'am. And on the horizontal, talking about what Macy just asked, on the horizontal, stretch and shrink both are the reciprocals, right? You see that? But on vertical, they both just are what they are. You see that on your chart? Horizontal, you got to flip it, but on vertical, you don't. Alrighty. Let's see what else we got to look at. Okay, this is just another way of writing something. This one says f of x is x cubed plus x squared plus 1. It wants us to have g of x be f of negative x. Okay, and we've got to write the function for that. So first off, if g of x is f of negative x, what are we doing to it?
Reflecting.
Reflecting it where?
Y-axis.
Over the y-axis. So we're taking this graph and reflecting it over the y-axis. But if the question wants me to actually write the function out for that. So I'm going to say g of x equals, and then all you're going to do, if you look there at your example, all you do is take each of your x's and make them negative. Now I can simplify that a little bit, right? Just a little bit. Negative x cubed, if it's an odd power and it's negative, it stays negative, doesn't it? But what about here? What does an even power do to a negative? Turns it to a positive. So that would be a reflection over the y. So that reflected that over the y-axis.
How does that turn into, like where you have plus negative x squared? How does that turn into just plus?
What's a negative times a negative? Yep. Yep. Yeah, let's do another one like that. That one was fun. We're going to let f of x be the same thing again. X cubed plus x squared plus 1. And we want g of x this time to be 3 times f of x. Alright, so first off, what are we going to be doing to it? Vertically or horizontally? Do what?
Vertically.
Yes. Everybody see what Macy said? This is going to be a vertical stretch of 3. You look down there where in the example it's got an 8x to the 4th. It just stuck a number over there in the notation. Just put a number, an a, in front of the f of x. So we just put a 3 there in front of the f of x. So what that means there is that we're going to take our f function and put a 3 in front of it. Which now, how do we simplify that? Add it here. So g of x would be 3x cubed plus 3x squared plus 3. Alright, I'm going to give you 4, back to the thing we started off with, 4 different transformations for you to describe. You ready? I'll write them all and then let you work. Number 1, f of x is x to the 4th. G of x is x to the 4th plus 3. Describe the transformation. Number 2, f of x is x to the 4th again. This time, g of x is x minus 5 to the 4th. Number 3, f of x is x to the 5th, scooting it on up. G of x is x minus 2 to the 5th minus 1. And then the last one, number 4, f of x is x to the 6th. G of x is x plus 1 to the 6th minus 4. Alright, see if you can describe those. Are all some pretty simple ones. So then we'll do one more after, or at least one more set after that. These are basically just scooting. After that, we'll look at some of the other stuff, the flips and the shrinks and the stretches. I got them. Need another second. Alright. Gracie, what number 1 do?
It went 3 units up.
3 units up is exactamundo. Good job. Caitlin, what number 2 do?
5 units right.
5 units right. Everybody good? Everybody good? Good. Mason, what number 3 do?
Right 2 down.
Right 2 down 1 is good. Everybody alright? And Courtney, what did the last one do? Very good. Left 1 down 4. Everybody's good on just scooting them. No problems there. Let's make sure we got the other stuff down. Let me give you 3 of these next ones. Alright, number 1. F of x is x to the 4th. And g of x is negative 2x to the 4th. Number 2. F of x is x to the 6th, and g of x is negative 3x to the 6th. That's kind of the same thing. Last one, let me find one a little different. F of x is x to the 5th, and g of x is 3/4 times x plus 5 to the 5th. Alright, describe what happened on those. Alright, we good? Need another minute? No problem, no problem. Good? Alright, what happened to number 1, Macy?
A reflection over the x-axis and vertical stretch axis.
Alright, she said reflection on x-axis. And she said vertical, look up now, stretch up 2. You good on that? Alrighty, so number 2, then, if you got number 1 right, you ought to get number 2 right. I just changed the number on all I did on it. Sydney, what'd you get on number 2?
Reflection over the x-axis and vertical stretch factor.
Had a kid. Good job. All right, then on the last one, it's not any more difficult. I just threw some other stuff in on it. Rose, what we got on the last one, sweetie? Left 5 is good, and this one was a horizontal. Oh, I'm not real sure about that. It would be, let's see, let's look back at my table over there. I'm thinking it's vertical. Oh, okay, and here's, to be a horizontal, and it tricked you because of the parentheses. I get why you would think that. To be a horizontal, the 3/4 would also have to be in the parentheses. But when it's just out in front of the whole thing like that, we're looking at vertical still. So that one would still be vertical. And then which one would it be? A shrink or a stretch? It would be a shrink. And does vertical stay like it is, or do you flip it? Stays is right, so it would be 3/4. Look at the examples on that chart you copied down. Horizontal flips it and vertical stays. Alright, pretty easy stuff on that. Not a big deal. We still got another graphing to look at. We're getting close to winding this down though. Tomorrow I have a meeting in Arkadelphia all day, so you're just going to have an assignment in your classroom. It's a factoring review. Remember we did factoring last week, so it's an easy factoring review. Won't be anything difficult. Turn that in to the sub, and then when I'm back after that, we'll go back to some more graphing stuff. Good deal. Hope you're seeing how this all hooks together a little bit, because it's showing up does.
Sally don't like graphing.
Why couldn't you make a chart?